This is Unit 2, Segments, Lines, and Angles. Preview Video 2.2, Part 2, Segments and Informal Proofs. Go ahead, close your eyes, take a deep breath in through your nose. Hold your breath. Slowly exhale. Sit tall. Open your eyes. Let's get to work. Taking a look here, you want to go ahead and write out the location, date, time, and get a parental sign-off. So we're going to continue our study of what are called proofs. Do not be intimidated by the word proof. What we call a proof could easily also just be called an explanation. A proof has three components: what, how, why. Read this aloud with me. Finger right there. Out loud, please. One of the key concepts in geometry is that this math subject is designed to teach you not simply what to think, but how to think logically and analyze the why behind mathematical principles. You're going to want this page in your reference booklet, these couple pages, handy. You might want to put a couple paper clips. One would be the page commonly known as algebraic properties, and then segment properties. Algebraic properties is in Unit 1. Segment properties, you filled out a couple lessons ago, is in Unit 2. You want to paper clip both. Very, very important. When working with proofs, you always start with the diagram. Geometry is about things. It is important you analyze the things on the diagram. That's what that symbol means. No naked diagrams. When working with a geometric explanation, you want to remember gift. Given, implied, freebies, and talk through. Given. You mark the given and the prove information on the diagram. I will usually use green for given and what we're trying to prove for red. You mark what is implied by the given information. Implied are things that are true because of the given. Then you want to locate and mark what's called freebies. Notice that's in quotation marks. That is not a technical term. Freebies are things that are always true, even if they're not in the given. So things that are true, even if they're not in the given. I'll explain that in an example. And then this is really critical. Take a moment and actually talk yourself through the problem. Start with something like, I know this, so this is true. As you talk through the logic of the problem, it'll make the writing of the proof a lot easier. Why? Because you can talk faster than you can write. So by talking yourself through the logic, it helps you organize your thoughts so that when you go to write, you can capture those thoughts and slow it down to the speed of writing. We're only going to do 2 together. So we're going to first read the given and mark it carefully on the diagram. So the given is the fact that segment CE and DF are of equal distance. So watch what I do here. C to E and D to F are of equal distance. That's my sound effect for hatch marks. Now, knowing that's true, we're going to try to prove, and remember, prove just means explain. Don't be put out by that word. Prove, we're going to try to prove that this segment CD and this segment EF are therefore congruent. So I like to put that in red with question marks. Given. Implied and freebies usually go together. We're looking for things that are true just on the diagram. And this would be an example of a freebie. This would be the example of a freebie. What's on the diagram is that CD plus DE equals that green segment CE. That's segment addition. Is that in the given? No. Is that a true statement because of the diagram? Absolutely. That's an example of a freebie. Here would be another one. DE and EF. Add up to DF. That is a true statement. And we kind of talk it through. If the overlapping segments, the green ones, if these overlapping green segments are equal, if we take away the overlap, what's left is equal. Did you hear that explanation? If you take away the overlap, what's left is equal. So at some point, take away, at some point we're going to be subtracting something. So our goal is to mathematically explain why in this circumstance, if the greens are equal, why are the reds equal? Okay, now we come down here after you've talked it through, no naked diagram. CE, DF are equal, and then you kind of look, why is that information true? Well, it's true because it's right there. It's given. CE equals CD plus DE. You come up here and you're like, oh, that's a true statement. We already figured that one out. I called that a freebie. Now the official name is simply little segments add up to big segments. We call that segment addition. Ooh, really creative there, folks, right? Now look very carefully. Do you see DF equals DE and EF? Oh, same thing. Look. Segment addition. Now, when you have a completely blank, you're probably freaking out trying to figure out what are you supposed to do. The question is not what should you do. Ask yourself, what's going on here? Look very carefully. It's like that game, What's Changed? Learn to circle stuff. Help your eyeballs catch. Do you see this? CE is equal to df, df. Now, because these are equal, these expressions are also equal. So we're going to replace CE with that expression right down here, and you'll see why in just a moment. And we're going to replace DF with this, and you'll see why in just a moment. Now, what is that called? You take something out, you put something else in. That's called substitution. And what lines did we use to substitute? We smashed together lines 1, 2, and 3. Now, keep track of what you're trying to prove. We're trying to connect CD and EF as congruent. Look super carefully. Do you notice now you have the exact same thing on both sides? Remember up here I talked about taking something away? We're subtracting DE from both sides. And when you do that, we end up with what we're trying to prove. CD is equal to EF. And the reason that's true at this last step is the subtraction property. We must use that word property. And what line did we use? Line 4. Okay, this one. You're going to follow GIFT, Given Implied Freebies Talk Through. Make sure you mark up your diagram. I'm going to be watching your preview notes very carefully. If your diagram is quote-unquote naked, untouched, unworked with, I will mark you down on these preview notes. It's very important you learn to process the information on the diagram. So pause this video, try this page on your own, and then restart. Welcome back. Let's see how you did. So we're saying the little segments have to add up to the big segments. So for this first one, AB and CD is congruent. Why is that true? It is given. Then you can list your other piece of given information. We come down here and we ask ourselves, why is AD congruent to AB plus BD? And that's called segment addition. Then we can do the other segment addition up here. CE is equal to CD plus DE, also segment addition. Now your ambition is to somehow connect these two. That's your ultimate ambition. So you don't ask yourself what should you do, but what can you do? And look very carefully. Right here, we could swap out AB and put in, we could swap out AB and put in CD. What can you do? We could swap out BD and put in DE. And that's exactly what we did in step 5. So that is substitution. And what did you substitute? You used steps 1, 2, and 3. Lines 1, 2, and 3. Now, why did that help you? Look very carefully. We can now say, see how these are exactly the same? Those are exactly the same. We can say what we're trying to prove is exactly the same. CE is equal to AD. And the reason is, again, substitution. And what lines did you substitute? Lines 4 and 5. Take a moment, review the main ideas of this lesson.